Hey there, I'm SourceMake and welcome to part 7 of the Java series, where we're going to expand upon classes and talk about base, derived, and abstract classes, as well as talk about how classes can be object-oriented and what object-oriented programming is. So as usual, I've got the resources right here on my website, and go ahead and click the link below this video if you'd like to get to the website. You should also come to the website if this is your first time in this series, because we've done a bunch of other parts and I've got a bunch of other videos. So if you need to catch up on stuff, then go ahead. And I know in the last video it was really complicated because we talked about how classes were blueprints, but this time we're going to look at classes. Hopefully you know how to use classes by now, but we're going to use classes in a different way to talk about how objects work and why you would use Java and object-oriented programming classes and why they're so popular. So I've got the Linux virtual machine open, and we're going to get rid of the code from last time. I uploaded it to GitHub, so again, if you really need this code or you want to view part of the code, go to this GitHub page and, just go to the part that you need. Maybe you need to learn about array lists, browse the repository at this point, download it, or click the part of the file that you need just to make sure that the code is there if you need it, is basically the moral of the story. So we don't need this and we don't need this. We are going to get rid of this stuff, and let's go ahead and do our usual making of this code to make sure that it works. Always do that, and it works. Okay, fantastic. So let's talk about objects. And yeah, so remember, classes are blueprints for objects, and in object-oriented programming, what you do is you have objects like people or cars, and you try to model your classes after those people so that it works and you can basically do the least amount of work as possible, is what the point is. And you'll see in our example that we are going to model animals in our classes. So basically, there are a whole bunch of animals, right? There's humans, there's weasels, there's fish, there's dogs, there's frogs, there's reptiles. There's a whole bunch of hierarchies of classes where you can get specific or you don't, but everything is under the branch animal, right? And there are certain features that are available just to animals that plants can't do, that TVs can't do, that computers can't do. And the way object-oriented programming works is you define the blueprint for the overall highest level thing that you can do. In our case, it's going to be animals. Then you trickle down to the next level of category for what it describes a problem. So in our case, we're going to look at mammals, and we are also going to look at, we're not going to look at, but besides mammals, there are fish, there are reptiles, there are birds, and there are insects. Those are the 5 basic animal types. I'm remembering 2nd grade really well right now. And from those mammals, there are different types like cats, horses, and we're going to look at dogs. And basically, we're going to define functionality at each step so that when we get to the final level, we can implement as little code as possible, and we can make sure that each one of the mammals gets all the code that's necessary for animals and mammals so that nothing gets left out. Like, for example, fish all have fins, right? For the most part, we're going to say all fish have fins. We don't want to define beta fish that does not have fins because we just forgot about it when we made the beta class. What we want to do is we want to make sure that every fish has fins, and anytime you implement a fish, which could be a goldfish or, I don't know, a trout, a salmon, they all have those properties so that you don't forget to implement them. And it also saves on code because you only need to write them in the above class, then you use it later. And we're going to see how this works. So we're doing animals, and that is going to be our example. So what we're going to do is we're going to create an animal class. So we're going to use a touch command to create an animal.java file. And inside of it, we're going to open it. And as usual, we are going to say class animal because every Java file has a class inside of it, and the class has to be the same name as the file name. And class animal, and what are we going to say? Okay, so what we're going to say for animals is every animal has a number of legs, right? That's what we're going to say. But we're not going to define an animal, right? That's just like a really generic term. That would be like saying define an electronic. Well, what do you mean electronic? You could have like a phone or a tablet. That doesn't make sense to define an electronic itself. That's just like a description of an object. Same thing for animals. You can say something is an animal, but there's not one specific animal. You have humans, you have dogs, you have cats. This is just like a generic definition. So what we do is we say the abstract keyword in front of this. And what the abstract keyword says is basically, okay, we've got this class named animal, but you're not going to be able to create any animal objects. We have the blueprint for animals, but it doesn't make sense that you create an animal itself because that's just weird. You need to be more specific. You need to say a squirrel or a dog. It doesn't make sense to create the animal itself. So basically, an animal is going to be like the hierarchy of all our animal classes, and any animal class after this, like our mammal class, is going to have to work from this animal, and you'll see what I mean in a second. So we are also going to define an abstract function because the abstract keyword works that way. Remember, the abstract keyword just says, okay, we're creating this now, but whoever uses this is going to have to define this. And okay, let me not mention it now. We're going to talk about base and derived in a bit. Let me not forget about that, because those are words that people like to use. And we're going to say that every animal has the ability to speak. Cows moo, dogs bark, humans speak. And again, because every animal has this, we're not going to define the function itself. It's a void function, a public void function, as you can see. But we're going to say abstract, which means that whoever defines a class that uses animal in the future is going to have to define it. So that's our overall animal. We know that all animals have legs and they all have to speak. Now, let's be a little more specific. We said that there are animals, but based on those animals, there could be mammals, fish, reptiles, amphibians, and birds and insects. Actually, okay, my second grade education, I think amphibians and reptiles are the same thing, but let's not worry about that right now. We have all those, so let's extend our animal class by saying that there's a mammal class. So we create a mammal.java file because every time we define a class, we need to do that. And I'm going to say, okay, we have class mammal because we always do that because that's the file name. And every mammal, well, mammals are types of animals, right? So we have to use the extends keyword to say that it extends animals. So remember, we have this overall class that's defined for animals. All animals have legs and speak, but we're getting a little more specific now for mammals. And we don't want to say that mammals have legs and speak too, because that would be like reusing the same thing. If we made a reptile class, then we'd have to copy this over, and that's just inefficient programming. Because all animals have this. There's no need to define it every single time and copy and paste the exact same code 40 times for every single animal. So the way to do it is to have one class, then extend that, then keep extending. And I'll give an example at the end of this video, I guess. So we've got this mammal class, and all mammals may be defined by having here. So we're going to have a Boolean variable here that has fur. Does this mammal have fur? Squirrels have fur, dogs have fur, cats have fur, humans don't have fur. I can't think of any other animals right now. I should have gone to the zoo before making this video. And we are also going to declare that all mammals eat. Technically, all animals eat too, but we're going to just say that this is something that only mammals do. So we're going to define that in the mammals thing. And remember, this is an abstract class, abstract function, which means that it's not going to be defined because, again, it doesn't make sense to make a mammal object. There's no such thing as a mammal in real life. So this is just like a definition. So what we're going to do is we're going to say this is also an abstract class, which means we're going to be extending this to someone else is going to have to extend this. So let's finally get to the final of it, and let's make a dog class. So we want to model dogs in terms of programming. And so we're going to make a class named dog. We've got the dog.java file, and inside, of course, class dog. And this one is going to extend the mammal class. Extends is the keyword. So again, a dog is a type of mammal, but a mammal is a type of animal. Well, so we know that dogs might have fur and they do eat because they're mammals, and because they're animals, they have legs and they speak. And we want to say that dogs can do certain things. Well, actually, we can define extra functionality for dogs, but for now, we're going to make a constructor first of all. That's what the code does, so let's follow that. So every time a dog object gets created, we want to define some stuff. And what we want to define is a dog has 4 legs. They just do. And a dog has fur. It's true. So again, even though we did not declare an integer legs in this dog class, it came from the animal class, which is really cool, right? So you don't have to, if we were making like a bunch of objects, like a class for dogs, a class for cats, a class for squirrels, a class for horses, then we would have to declare legs every single time, and that's just like a real time waster. That's really bad because you might forget, or you're copying and pasting so much in different files that your code is like this big for each animal, and that's just dumb. Instead of doing that, you can define that as part of an animal, and dogs are animals, so you just borrow it. It's still there because you defined it as an extension of a mammal, and a mammal is an extension of an animal. So just make a note that we do have access to variables and functions that were defined in the base class, and let me define that right now. So there are these things, and the way people talk about it is there are base classes and there are derived classes. The base class is the animal class. It's just the base. It's the building block. And the mammal class would be the derived class because, you got the base class and you spin off a little and it derives into the mammal class. If you know calculus, you know derivatives, it's sort of the same thing. If you don't know calculus, you kind of should because computer science and math are really closely related, but that's a different story. The mammal class is derived off of the animal class. It doesn't exist by itself. You spin off the animal class to get the mammal class. And also, the dog class is spun off of the mammal class, so the base class in this case would be the mammal and the derived class would be the dog. That's what base and derived mean. Base means the one that doesn't care about anything. It's base. Derived means you took it from something else, so it's a spin-off. And because this is a spin-off, it has access to the base class stuff. And what else did we have? We had these 2 functions. We had eat in the mammal class, and we had speak in the animal class. And it doesn't make sense that an animal speaks, like to define that for an animal, because different animals do different things. Cows moo, but what do dogs do? Well, dogs bark. So we are going to define the speak function here in this class. Remember, before we just kind of prototyped it by putting a semicolon after declaring that it exists. Now, to use this, we have to actually define it. And I'm going to show you what happens if we don't define it in a second. So what does a dog do? They bark. Now, let's try to make this and see what happens. Actually, it's not going to make sense yet. Actually, fine. Let's do it really quickly. Let's use our animal class. Our dog class in specific. So we're saying, I don't know why the indents are like so far away. I'm not going to change it, but that's kind of annoying. So we've got dog. So again, you learned this in the previous video. You do the class name, then you name the actual variable itself, which in this case is source dog. That's the name of our variable. And we say that we instantiate it. We're saying that it's a new dog. This declares a variable named source dog, and it's of type dog. And this part says, okay, this was the blueprint and we're declaring it, but we actually need to create the object. And that's what this does. It instantiated, that's the word, by saying new dog object. And you use the constructor to construct it. That's what the constructor is. That's why it's blank. So we created a new dog object and it's of the name source dog. So we're going to call source dog dot speak because we define that, right? We define the speak. Once we call speak, it's going to print bark. Now, let's save this, and let's make. And it does not work. Wait, oh no, I said this wrong. Damn, I was so excited. Okay, source dog dot speak. Make. and it does not work. Why doesn't it work? Dog is not an abstract and does not override an abstract method in mammal eat. So remember, when I said that we declared something as abstract, that means it's kind of okay, all mammals eat, but you're going to have to define this later because I'm using the abstract keyword. We didn't define what dogs eat, and that's going to throw an error. Our code is not going to compile. So what we do need to do because of the abstract keyword is it says, okay, you didn't define eat. You need to define it if you want to actually have the code work. You can't derive a class off of an abstract class without defining all of the abstract functionality. You always need to define the abstract functionality. And the reason you didn't have to do it here is because this is another abstract class. Because remember, this speak was abstract, but you didn't have to define it in mammal because there's no mammal object. This is also abstract. I don't know if that makes sense, but I'm trying to explain it in a way that does. It should make sense. So we're going to define eat as system.out.println. And when dogs eat, what do? They print to the console, I eat bones. That's what eating does. This is a little bit of a simple example, but when you get more complicated, as long as you understand the intuition, you can use this. So let's use that now. Source dog. We're going to have source dog dot eat. And let's make, and it works. So the code compiles, it barked, and it spoke. And this is how you use the object. So let's do a quick rundown really quickly of what happened. We declared this animal class, and it's an abstract class, which means it has something that needs to be defined from the derived class. Animal class is just a blueprint. All animals have legs, and all animals speak. Then we get a little more specific, but not really specific, by extending the animal class to mammals. So there are other definitions of animals that could be mammals, and mammals are a type of animal, right? So mammals could have fur, and they have a function that lets them eat. But there are no such things as mammals by itself in nature. That's not specific. So what we do is we say that it's abstract, and we declare this other function abstract so that we know we have to define it later. We get to the final level, dog, and dogs are real. Dogs are really object. They exist. So we extend the mammal class because that's closest to it in the hierarchy. And we just set up a constructor, and we say dogs have 4 legs and has fur is true. And there were 2 abstract functions, specifically dogs eat bones, and the way dogs speak is by barking. So we fill in that functionality that were from the abstract classes that were bases of the dog class. And then, of course, to use the dog class, you just have to say, okay, the class name and the variable name that we're going to choose is this, and then we say, okay, that's the actual variable declaration, but we need to actually create an object for this in memory. So use the new keyword to create the object, and what is it? It's a dog. That's the class name. And there's nothing in the constructor. You kind of know what constructors are. You don't need to pass anything, and that makes the object. Then you can actually say, okay, we've got this thing called source dog. We can use it to speak. We can use that method, or we can use it to eat. And that's basically what object-oriented programming is. It's basically a hierarchy of classes so that you can define certain things. The whole point is to define real-world things by having them have properties and things they can do and variables that describe them inside of a class. But to be like really good at it, you don't just declare everything in dog, like, because otherwise, when you have similar things like cats or squirrels, they would also have to have the exact same code, and that's like bad practice to just copy and paste the same thing every single time. To say, okay, dogs have a variable named legs, cats have a variable named legs, squirrels do, stuff like that. You can't continue like that. The good way of doing it is doing a hierarchy way by saying, okay, there's things called animals, and of those animals, there are different kinds, called like mammals and fish. And of those different kinds, well, a dog is a type of mammal, and you kind of get that hierarchy, and that's how object-oriented programming works. So if you get this video, you actually know object-oriented programming, which is honestly crazy. It took me like 2 years to really just understand programming by itself and then understand how objects and classes work, because maybe I didn't have a good teacher for that, but I tried to make it really simple, and that's really how it works. So I think I did a good job, to be honest with you. I think that's really good. So let's add this to Git. I'm going to show it to you because this is a good project. This is really, so what is this? This is video 7. This is abstract classes, bases, derived, objects, whatever. And let's push this. Remember, you should be going to Git, and it's really important that you try this code out yourself. Maybe you can define a squirrel class and a fish class, and the way you get good at this is you practice it. So that's it for now. In the next few videos, we're going to be doing generic types and complex data structures, and maybe some other stuff that I'm forgetting. So I'm SourceMake. Thanks for watching the Java series. Hopefully you'll learn more, and remember, practice.